This is Sunday, June 25th. This is video number 19. I'm going to show something in my book today. I got a lot of ground to cover. I'll start by saying when we change the periodic table, religion will go away. Now, it's not going to go away immediately, but it will gradually go away. And if you're like me, you'd like to see it go away because it's false. Some people don't know that it's false, so they want any chance they can to live forever. They want a chance for immortality. So they want to keep it hanging around. I know it's false. I'm not afraid of it in the least because I got into it so deeply and took what it claimed, took its theme so seriously for so long that I knew it was either going to, the deity behind it was either going to be concerned about what he emphasized or he didn't exist because it's man-made. Guess what? It's man-made. You can't thoroughly check it, test it, and that deity stands up to testing. It doesn't work out. Sorry, we're going to have to face the fact that we evolved on this earth like other animals and like bacteria and microorganisms, krill or dogs and cats or whatever. When we die, we die. We don't hang around. We don't come back and spook people. There's no end of the world that some deity wants to happen, so radical Islam needs to conquer the world. We need to forsake all we have and follow Jesus so that we're ready to be martyrs at the end of the world, so that Israel can be raptured right before Gog and Magog come up and the camp of the saints in Jerusalem, and then fire, and then they're raptured right before fire comes down from heaven from Jesus and burns them all up. Then we go to a new earth. That's all garbage. Okay. Get your head out of that trash. Work on something that's actually real for a change, if you're into that stuff. Okay. This is in my book. I've got on my computer screen right now, if I can keep it up. A series I did in 2012. I was really trying to get this, what I'm presenting now, get it organized and together. The name of that series is Particles, Radioactivity, and Light. And that's when I really started to lay down what I'm talking about now. It all had to be refined, obviously. But one of the main things in that series was this. Now, this is a remake of it, the original one. But this is what you see when you're... there's a lot of videos you can find that they show in schools where they have two very strong magnets, probably electrically activated, that send a current from a south pole into a north pole. That's what those two gray curved things supposed to be, the ends of those magnets pointed right at one another. The little black thing at the bottom is like a lead box with a hole in it. Inside is either thorium or radium, something that will emit alpha particles. They've got material, emitters of alphas. They also have emitters of betas. They have some radioactive materials will emit both. But when doing this test, what you're doing is setting up a screen on the other side that will detect where the alpha particle lands or where the beta particle lands. So you're watching for deflection to see how to interpret that. And the beta goes pretty much straight, the alpha goes pretty much straight ahead. isn't deflected much because it has a lot of mass. I think there's a little bit of deflection that's interpreted as positive charge, but it's very little. Uh, there's actually a much better explanation for that than negative and positive charge. Um, the beta makes a longer track. What you've got going on with magnets, which hasn't been understood correctly yet, is that you actually have electric photons, which are the center charged uh, photons in my system. There's no negative charge. You go from uncharged photons all the way up to the highest charge types, and there's little increments all the way up. I have a 13 particle system that's representative of that. The 13 particles, that's enough to do the job. Every one is a different shade of a color, and it gradually leads to the next one in the shade. 13 gets the job done. There would be charges in between each of those 13 out there, but 13 is enough to be representative and get the job done and cover everything we need to talk about. Anyway, what's thought is that the alpha goes one direction because it's positively charged, and then the beta is supposed to be an electron, and it goes the opposite direction because it's negatively charged. But what's actually happening is those electric photons in my system, the yellow, green, and the yellow, are flowing from one pole through the material, from one pole, the south pole, let's see, yeah, the south pole into the north pole. And it's not perfectly neat. It's messy. There's a lot of attracted photons in the environment that also see what you have with magnets. Let me set this down. What you have with magnets, it hasn't been understood yet correctly, and it's not really that difficult. The very first thing I did when I started to study physics, I took 2 bar magnets and tried to observe and decide what was really happening. And this has everything to do with electric current, how electric current is generated in a dynamo using magnets. What's going on with that? Anyway, if you ask a scientist if a bar magnet's 2 poles, 2 north poles that repel, are those both positively charged or are they both negatively charged? And the other 2, are they, okay, let's say the 2 north poles are positively charged, and then you turn around and the 2 south poles are those negatively charged? They might say yes. That's where things stand right now. Now, it shouldn't be like that, but that's, now if you, the reason why this is so important, because this is how the periodic table is established right now, based on a belief in negative charge. And if those are actually, what's really going on with magnets is that photons from whenever you have radiation that's intense enough, like say from the center of the earth when there's compression, or in a star where there's compression, well, let's just talk about the earth. When you have enough compression, you're going to have outflowing radiation. And I'm not going to go into all the details of that, but when this stuff is moving out, it scours off some of the outermost photons on nuclei. And when that happens, there's a deficit. When that they need those to neutralize, or much better neutralize, the material than it would be without them. And so there's a deficit. And then when that material, let's say magnetite, rises up in lava on the surface, and it's magnetized, okay, it's experienced that. And so it's what's going on is that everything becomes polar. Uh, the the reason it's polar is because the material's molecular structure. The structure simply blocks entry from the sides. Now, they could enter from the sides, but it's difficult because of the way the material is arranged structurally. So it's easy to enter the north. That's all there is to it with poles. It's when you got magnets. It's easier to enter and exit, to move in one direction. That's all there is to it. And so these photons that are just all over the place in the environment are attracted to come in and fill those deficits. That's all there is to it. When you already have some that have come first and they're circulating around, that's what you have with that strong magnet. But it's when they're passing one end into the other, there's also some coming from the environment that are also attracted, want to land in those spots. When they can't land in those spots because fill the deficit, because the ones behind them are always also vying for those same positions, and they try, and so they're knocking them on ahead, and everything just keeps flowing. That's why when you take a hammer and you hit a magnet, then it demagnetizes it, because now you've caused a vibration which slows everything down, and then some of those can land, and there's a much less deficit or no deficit anymore. But the periodic table is based on the belief that negative charge exists. There's no reason for negative charge to exist. If you don't need it, it's Occam's razor. Get rid of it. And what you have with my system is a system where, you see, there's two phony baloney things, in my opinion, with what we're using right now in physics. And it just caters to religious faith. And those are negative charge and radiation forms not having mass. That's just like petting religion. Oh, we don't want to get rid of this wonderful religion. Religion has helped us in some ways. It reminds us to be altruistic. In the name of altruism, I'm running off on a tangent here. In the name of altruism, we're told that, oh, it's justified because humans wouldn't be altruistic if they weren't reminded and told by religion to be altruistic. Jesus originally came up with some altruistic sayings. He was a very sincere person in what he was doing, a nutcase apocalypticist, however. Nevertheless, he's trying to be responsible socially, and which included some altruism. I think we can be altruistic without religion telling us to be altruistic, okay? Anyway, so getting back to the physics part of this, what you've got in this system that would replace that. Okay, now the center unit of a proton has the highest charged photon in the center. Because it needs a lot of uncharged and low charged photons covering it over. Everything is attracted by charge contrast, so they would cover it. But now the problem with a lot of low charged and uncharged photons covering the highest charged photon to stop it, to neutralize it, because they're attracted. Then it hasn't been neutralized yet, because now you've got these uncharged that are and low charged photon that are attracted to the middle charged photons, which cover it over, and they repel one another, and so it stops adding mass. That's what you've got inside the central unit in both a proton and a neutron. In a proton, it's the next in line. It's not as highly charged as the white. And so it takes fewer low charged and uncharged photons to cover it, and then it takes fewer middle charged photons to cover those. And then and anyway, what you've got is basically a center unit like that. And then around it are 14 positrons. And it makes a nice sphere. Now there's probably other stuff attached in between the valleys. It makes an even better sphere. But those are basically protons and neutrons. And in tritium, you can see how to set up a different base periodic table. When you don't have negative charge, you have what you've got in tritium is you've got one proton and two neutrons, and it becomes a radioactive substance because of that. And what's going on is the charge contrast in the protons, or excuse me, in each neutron, the center to the surface repelling the attracted low charged and uncharged particles in each one make it highly attractive. The proton is milder. That's why it can touch other protons, but they may not attach that well. And there's no problem, not like there is with two neutrons. And but the protons are mild enough that they don't cause banging. They just attach to neutrons. But in tritium, the two neutrons are so highly attracted interior to surface, that when they come together because they're so highly attracted, now the surfaces have more repelling particles and then they push apart. But then they're attracted, and so they clap. And this is what's going on in tritium. And you can make an entire periodic table based on that. And I've already started configuring nuclei based on that, and that determines how many protons and neutrons are in each nucleus. Now, when you have radioactivity, let's say, and then you have a daughter isotope that results from a radioactive substance, an element, and it transforms into another element. Let me just say, I make a note about that. The nuclei tables, the people who do that, it's great work, but I think there's some extrapolation. When you get to things that you can't measure to make sure what they turn into as a daughter isotope, then there's some extrapolation based on the parameters of the system they're using. To be sure that you're correct about what results after a moment of radioactive activity, and then there's a change, the element change. What actually happens is typically what happen is the nucleus would actually come apart. And when it comes apart, because what you would have left is a different number of protons and neutrons. And a certain number of protons and neutrons will always make a certain element. It happens automatically. No one needs to make it work that way. It happens. The reason it happens is because whenever you have some neutrons that are wanting to collab, and the protons are also attracted, well, they're coming in and sliding in between those neutrons that are wanting to collab, and so then they end up calming down, and then it wedges, and then that makes it. Every time when you have the right number of protons and neutrons in a small locale, in a small area, they will make a certain element. And this is what's going on automatically by that activity that I just described. You don't need negative charge to explain this. You don't need anybody making it happen. You don't need an explosion to make it happen. It's just going to happen automatically. But this is how it should be arranged. So the periodic table looks like to me that they've done a great job as far as mass. But your protons and neutrons would actually not vary in mass by that much in the number of photons they have. It looks like to me the proton has 1,836 photons in its mass. The neutron 1,864. So that's less than, that's what, 28, a mass of 28 photons difference. It's very little. So you're not going to know by mass whether a nucleus contains how many protons and neutrons. They're just going to be nucleons when they're that close in mass. And so you can, in my system, when you're trying to keep neutrons separated, is the determining factor for how all these are arranged and configured, etc. Then you would have, in some cases, such as 7 neutrons combined with 28 protons. And you would be in the range of about 20% neutrons most of the time. When you get too many neutrons, then you got a problem, because they're going to, if they can get together and clap, then you're going to have it's going to be unstable radioactivity, and all that clapping produces. It's the neutrons are the problem with that. So that's all there is for right now. If I can say more about religion before I quit. If the universe, if there's no spiritual, see, my system is a materialist view of the universe, and so when you break it down to these digits, every digit has mass, and these digits have always existed in the universe. They didn't have a beginning. Then and if that became accepted, then and then this system, was arranged, and we did the periodic table according to this. Then, and it was accepted. Well, what would happen is you'd have some that are working on this, and some that say, yeah, I don't like religion. I think this is how it really is. Let's make a periodic table like this. And so we work on that and refine it. And then there's going to be other schools out there, universities, colleges, whatever, and they're going to try to retain the old system. So there'd be a clash there. But this system will win out, and religion will diminish, and this doesn't allow for any spiritual realm. Everything, the nerves in our bodies that give us feeling in our brain that we can detect, it's all happens by electric current. My system explains electric current in its minute detail. There's no reason to have afterlife, where I'm like the other animals that evolved here. I don't leave my body and then go and haunt somebody, or become a ghost. And we don't need an end of the world scenario. We don't need radical Islam thinking that it needs to take over the world. I'm sorry to say, but to address these problem children of religion, you need to address religion itself. And once this kind of system is adopted, then there's no reason not to adopt this system, where everything has to have mass, where it's explained down to its minute detail and to its very smallest digits. There's no reason to not adopt this system. You may want to think that there's a spiritual realm, and you think that you're interacting with a deity, and you're going to live forever, that you're superior to people that are going to end up in hell and all that kind of stuff. But that's all garbage. Anyway, that's video 19. One more note I was needing to add about that. I was trying to cover so many things in this video that when I was talking about the 2 magnets in the book, that are in videos you can find that they, teach in school. Um, Pull it up again. Anyway, there it is again. That one. Um, there are eddies formed because what I was saying, I got on to some other things that needed to be explained and didn't come back to it. But what happens is when they're flowing, let's see which way they're flowing. Okay, they're flowing south to north. And what happens is a lot of these electric photons from the environment are being pulled in as well. And so there are too much, there are too many at the entry point of the North Pole for all of those to squeeze in. And so what happens, because the ones from the environment are coming in too, as well as the ones that are being coming out of the South Pole. So what happens is eddies form. These particles that can't enter because there are too many. They don't just leave. They're still a deficit. They're still attracted, just like the new ones coming in. And so eddies will form. And these eddies are responsible for the beta. The beta makes a curved path, the opposite direction that the alpha goes. And that's interpreted right now as negative charge causing that. No, it's eddy. Eddies are causing that. Okay. I failed to come back and clear that up, point it out. So that's what this is.